Variation.
Very good. Okay. So we're going to go through partial variation today. We have a graph, and we're going to be looking at a taxi fare. So this is the information we've been given. It says it costs $2 to initially start a taxi meter. It then costs another 50 cents per kilometer. Okay. So, yesterday we talked about direct variation, and direct variation is when we go through the origin. Partial variation does not go through the origin. Okay, it'll go through some other part of the y-axis. So in order to figure this out, we'll have to figure out what our independent and our dependent variables are. So when we look at these, what are our independent and dependent variables? Travis? The $2. So are we measuring money along here? So the more money I spend, therefore the farther we go in the taxi? What if I give the guy 50 bucks and get out of the taxi? Did I go anywhere? No. The kilometers are our independent variable. Okay? This is our independent variable, which means what axis is this on? Yeah, that's our x-axis. So our x-axis is our kilometers. What does that make our y? Not 50 cents, but how else can you define that? Yeah, your cost, the amount of money you spend, right? So our money, all of this, the money is the y-axis. And we usually represent that with a dollar sign. This is our dependent variable, which is on our y-axis. So the amount of money that we spend depends directly on how far we go. Now, what if we just step in the taxi and then get out?
It's free.
Is it? It costs me. It costs me $2, just like they said here. The initial fee to start the taxi meter is $2. So if I don't even go a kilometer, I still owe this guy $2. And this is not going through the origin. If it cost us nothing, that would be called direct variation. That's going through the origin at 0 and 0. But the y-axis, where we're crossing our y-axis, is at a value of 2. What coordinate is that? 2, 0? 0, 2. Excellent. Okay, so this is a partial variation. We're varying. We have an initial fee to start up. Okay? And then from there, it costs us 50 cents. So after I go a kilometer, how much do I then owe him? $2.50. Okay? And what if we go 2 kilometers? $3. And this pattern, is it the same all the way through? Yes. So what type of relationship would you call this? Yeah, it's definitely positive, and it's a linear pattern, right? We're going up by the exact same amount every time. So for every kilometer that we travel, okay, for every 1 kilometer, how much is our cost increasing? Yeah, so I'm going to put $0.5. 50 cents is our increase for every dollar. So if you guys recall yesterday, we talked about direct variation, and we represented it with a y equals, and we did something called m and then x. Our m was how much we were changing by every time. So what is that in this case? 0.5. Excellent. Okay. So our m is equal to our 0.5. That's what we're changing by every time. So we have y equals 0.5 x, but this isn't direct variation. We started somewhere. And what value did we start at? 2. That's right. So for partial variation, the formula changes a little. We add a b, it's called. Okay? And this is known as the y-intercept, so where we start. So what is our y-intercept? We just said it. At 2. So it's a positive value of 2. So our b value is equal to positive 2. So we're going to replace b with plus 2. And this equation will tell us how much money we owe depending on how far we travel. Okay, so we've just created an equation for above. Y is equal to 0.5 x plus 2. So let's think about this. We know from our graph that at $8 8 kilometers we owe $6. But let's say I have to travel halfway across Toronto. Okay, so I'm traveling 50 kilometers. Which one am I replacing? The y or the x? That's right. X was dealing with our distance. So we're going to replace x with the value of 50. Y is equal to 0.5 times 50 plus 2. Yes. What is 50 times 0.5? $25. Good. Plus 2. So we owe them how much money? $27 to get across the city. No, it's not real.
Hello, welcome back.
Okay, so we have two internet companies we're going to compare. And we're going to compare these two, and each of them will be essentially a different equation. And what we're going to find out is one will be direct variation, another will be partial variation. So we're going to look at the two. Company 1 has a price for every 1 gigabit of data used. The cost is $2. Okay? Company 2, there is a $10 startup fee, and then for every 1 gigabyte used, it costs $1. Okay? So let's go about setting up a graph, and actually in order to do that, we're going to need an independent and a dependent variable. What is our independent variable, Travis? The dollars is the independent, so the amount of money I spend depends on how much data. I think it might be the other way around, because they're going to charge me depending on how much data I use. We are. So, depending on how much data we use, let's argue about it. So, our independent is our gigabytes. So this means our gigabytes of both of these are going to be our x-axis. Okay? These are independent variables. Which means what is our dependent? Depending on how many gigabytes we use, what happens? Our cost increases. So the amount of money we use. Okay, this will go on the y-axis. This is our dependent variable, which is our y. Okay, so let's count up by this. We're going to go by ones. And we're going to see which is more beneficial at what point. Okay? Yeah, we're going to use one giant graph for this. So on our y is our money, our cost. And on our x is our gigabytes. Got axis on the line. So let's talk about these two companies.
Language.
So let's look at the very first company, Company 1. If we use no data, how much do we owe this company? Zero. We owe them no money at all. Okay? So that already lets us know, assuming this is going to be a linear relationship, what type of variation is this? This will be our direct variation. It's going through the origin. And then from there, for every 1 gigabyte we use, how much does it cost us? $2. Okay? So when we use 2, we go up by to 4. 3 we go to, and then 4 we go to 8. Okay? Now, what type of relationship is this? This is linear. Okay? And we want to make an equation out of it. So for every movement on the x, for every 1 gigabyte we move, how much does our cost go up? $2. So if we were to make an equation, remember direct variation, and we're going to use the same equation for both direct and partial. Y equals mx, and we're going to actually include the b. Okay, I'm going to show you how we still get direct variation. What is our m? What is it changing by? 2. So we're going to replace 2 for m, and in direct variation, our b is where we cross the y-intercept. What value do we cross at? 0. Do I need to include that 0? So y equals 2x, right? And that represents our first one here. Now let's look at our company 2. I guess I should have done that in red. Company 2. If I buy the plan and use absolutely no data, how much do I owe them? Oh, I should have used a much better example. Let me say it's $4 instead. Okay? Just because it's not going to fit on our graph. We'll say we use $4.
Why not 5?
Okay. And then, for every gigabyte of data we use from there, what does our cost go up by? $1. So at 1, how much do we owe? At 2? At 3? At 4? At 5? 9. Okay. What type of relationship does this have? This is again linear. And for every movement on our x, so every time we go a gigabyte, how much do we go up by? $1. So let's set this up in green. We know we have y equals mx plus b. What is our m in this case? 1. So our m is 1. And what is our b, our y-intercept?
4.
That's right, positive 4. So our equation states y equals 1x. Do I need that 1? I can kind of just write x plus 4. So we have two very different equations. This one is which type, direct or partial? And this one here? Partial. Now, this is what I want to ask you. When, depending on how much data I use, when is it more beneficial to use the direct variation? This one here.
At the beginning.
At the beginning, but I need a specific number. 0 to what? To 4. If I only use 0 to 4 gigabytes of data, right, at 4, what's happening? Does it cost more at 4? At 4, we're at the exact same price. Okay? So anything before that, this is where the line is below, it's more beneficial to use this direct. I might as well go with that company. But if I use a lot more than that, it makes more sense to use the partial variation for anything 4 and above. Because at that point, this line is above the other. Okay? So let's take a look at it.